Friends, in this lecture we are going to learn about Internet Control Message Protocol. So what is Internet Control Message Protocol? So it's for error handling in the network layer. So different types of errors can occur in the internet, and the Internet Control Message is for reporting those errors and for debugging the network. So for example, let's say we are sending a packet to some destination. So what happens if the router cannot send that packet? Then it will send one error message saying that I could not deliver that message to the other destination. So let's try to see. So we see here that IP protocol has no error reporting mechanism. So it has no error reporting or correcting mechanism, so it uses message. So you can consider always the network to be kind of a group of people, so like routers. So if I'm sending you are sending a postal message to someone, and let's say it was not delivered and it was somehow stolen in a in-between city. So if no one reports you anything, so you will think that okay, the mail has gone to the destination. But if you report the error, then he can very fast know that it was not sent and he will resend that message. So this is the benefit. So ICMP resides in the IP layer itself. And ICMP is there in the IP layer, and the message format is there will be ICMP message. It will be along with the ICMP IP header, that who is the sender and who is the receiver of the packet. So ICMP message are usually divided into two categories. So this is a lengthy verbose lines are there. ICMP messages are divided into two broad categories. One is for error reporting. So I will be reporting some error message that something wrong and has happened. Another one is for debugging, and it is query messages, that I want to ask my neighbor that are you there, are you still there, are you alive, or something like that. So if let's say there are two computers on the machine and I want to know if this server is still running, so I can send an ICMP echo message that are you alive or something like that. I can send a message, query message, to synchronize our clocks saying what is the time. So these are there. Let's move forward. So we will now look at message format of ICMP. So whenever we speak, so we have kind of some format that what all will I need to send. Error reporting messages, there are query messages, and checksum for finding if there is any error. So let's see the message and its format. So ICMP message has two things. It has a category. What type of message is it? So is it like, first thing you can find is it what is an error? Inside that you might find the category and there is code. So type tells us the type of the error, and then the code inside that tells us the subtype. So destination unreachable. So somehow some router will tell you that I cannot reach the destination. So this is an error message which tells to the source of the packet. Then there is source quench. Time exceeded. So all these we will learn very soon what are they. So then you have query message like echo request and timestamp request. So what is the message format? You will have 8 bits that represent the type. So when you get an ICMP message, to read the header, the first 8 bits will tell you the type of the error. Next 8 bits the subtype. What is the subtype of that error? Destination unreachable. Is it coming from the host other destination, then it will have different subcode. Okay, if is it coming from some router, then it will have different code, and then rest of header will be there and checksum to detect some error in the packet. Okay, ICMP always reports error message to the original source. Okay, so why is that important? So there is a sender, I'm going to send to some destination. Let's say some router find that destination is unreachable. So to whom should I send the error to? So I will send the error to the source of the packet, because then I should send it to someone who was sending, not to the destination, isn't it? So if you are sending a post, okay, postal mail, then if there is some problem, I will send it to the sender. I will report the error to the sender, not the receiver. Okay, so similarly, if there is some error message, I will report it to the sender of the message. So what are the different errors that can occur? So we said destination unreachable, source quench, time exceeded, parameter problems, and redirection. So these are some of the broad categories that you can easily identify using the type of the error message. So this is telling how our contents and data fields of the error message. So first one that we will see now, error message, is destination unreachable. Okay, so these are some errors that can occur in the internet. So a source is sending to a destination and someone finds that, okay, the destination is unreachable. So how can you know that? So if a router comes to know that, he will send you an ICMP packet. Okay, and in that he will set the type to 3, which tells that, okay, this type is 3, from where it will understand, okay, this is destination unreachable. Code will be, it's a 4-bit number, so it can be 0 to 15. So it tells that, okay, was it sent from the destination itself or from some intermediate routers? They will have different codes. So this is there. So you see, destination unreachable message with codes 2 and 3 can be created only by the destination host. Okay, so destination unreachable can be sent by the destination itself. Okay, for some reason, if the destination doesn't want to process any of the message, so it will just send a reply to the source saying that destination is unreachable. So here the type will be 3. I think the type was 3, but the codes will be different. Okay, so it will tell the subtype. So is it destination unreachable message reaching from the destination or from some intermediate router? Other destination unreachable messages can be created only by the routers. So this is there, and a router cannot detect all the problems that prevent the delivery of the packet. Now in the internet also it tells that there is no flow control or congestion control mechanism at the network layer or the IP protocol. Okay, so what happens is that your network layer is only concerned with sending the packets. So I get some packets, I will be sending those packets. I will not think that, okay, is the receiver ready to take those many packets, or is there congestion in the network so that I should send less number of packets. So there is no mechanism, at least on the IP layer. So this ICMP provides some feedback here. So this is called source quench. Source quench. So what it is, if let's say this is a router and sender is sending. So if I'm sending at a very high rate, okay, and let's say that the router or some receiver is not able to cope up with such huge data rate. So it's something like I'm teaching to some students, a group of students, and they are not assimilating so fast whatever lectures I'm giving. So they can give me a feedback that, okay, please teach us at a slower rate. Okay, so I will now take only 2 lectures in a week or something like that. So source quench is something like this. So if for sender, there is a receiver feels overwhelmed, he will send a source quench packet, ICMP error message, which will tell please stop or please send at a lower rate. Now what is the code for it? So the code for it is type 4, code is 0. Okay, and what happens is when you are sending any ICMP message, so what do? First is any router that is sending an ICMP message, so it will be an IP packet, okay, and it will have the source address. So initially, let's say packet was going from source to a destination. Now this one, what it will do, when the ICMP error message will come, it will have source is equal to the router, destination equal to the source of the original packet. Inside that, it will also put the header plus first 8 bytes of the datagram data, so that you can identify that, okay, for which packet the error was generated. Otherwise you cannot know that. So source quench message informs the source that a datagram is discarded due to congestion in the router or the destination host, and so the source must slow down the sending of datagram. You please stop sending or slow down so that I can manage. So that's the idea. And one source quench message is sent for each of the datagram that is discarded. And then what happens? So what will happen with this? What good happens? So let's say we had 2-3 senders were there at a router or to a receiver. They were all pumping packets very fast to it, which the receiver could not handle. So it will send a source quench message to all the 3 that please send a little slowly so that I can manage all the processing of the packet. So this way, if he sends, the congestion will then also decrease. So this is still the source quench. In the next lecture, we will look at other problems that are time to live, time exceeded, and other problems. And in our last lecture on ICMP, we will see to request, ping, and trace route, how they are handled using ICMP. So I hope you understand this. Thanks a lot.